I just had a call come in, and I got something I thought about a few weeks ago, and the customer that just called me, remind me of exactly what we're going to talk about today. Guys, are heat kits worth fixing or replacing? And guys, I found some new markers. I got to give these new markers some burn here, so I know some of these are dried out. I got to replace the old ones that I got here. But guys, what I'm going to do is I'm going to draw the system that this customer just called me about. And guys, for reference, real quick, this customer that called me, she has, I believe I made a video the last time I was here. I believe this customer has a AC only condenser, and I think she has an air handler inside with electric heat. And once again, guys, I told her with that setup, only having electric heat in the winter, that her electric bills are going to be high. Supposedly, she tells me, based on the set point she keeps it to, the bills aren't really that high between November and February. So, guys, at this point, she's okay with having high energy bills. But, guys, one thing I did tell her the last time I was out there, I think I replaced the thermostat. I told her that that particular air handler, I forgot what brand it was. I think it was the ICP. But she said, I told her that even though everything was running the last time I was there, I tested the heat and the AC, everything was working fine. I did tell her that down the line, knock on wood, if she ever did have issues with that particular air handler, whether it be the electric heat kit, it's going to be tough for us to find parts for certain brands, with age, I'm talking about the 30-year-old air handler. So, guys, and once again, she actually called, I think this had to been like at least a month when I was out there, but she said that last night she turned the heat on, and right now only cold air is blowing out the vents. And I walked her through the thermostat that I put in. I pretty much made sure that she had the set point set high enough, and she did. And guys, I mean, nothing else was done after I left. And she said that all the breakers are on, no breakers trip. And guys, I mean, based on how she was explaining it, putting two and two together, I think something's going on with the electric heat kit inside that air handler. So, guys, that's bringing me to the point of the topic I'm going to get into right now. Are electric heat kits worth fixing? So, guys, with that being said, let's jump into it. So I started writing this up here. And, guys, like I said, my handwriting and my drawings, it is what it is. I can explain it better than I can write it. So, guys, this is just your conventional electric heat kit. Regardless of what the KW is, you have your electric heat kits, you have your heating elements, which is the coils, right? And you see here, LS, you have your limit switches. And here in green, you have your relays or your sequencers. And guys, I don't want to get too technical with the elements of this electric heat kit because that doesn't really matter. But as you see here, you only have really three components. You got the obvious element, you have your relays or your sequencers, and you got your limit switch. Now, guys, assuming you know what the electric heat kit is, what it do, and hopefully you know how to diagnose it. The point is, guys, from my experience, I damn sure don't think electric heat kits are worth repairing. Now, guys, I don't want to be a hypocrite. I only had, and I can count on one finger, how many times I tried and how many times I actually had some success in fixing electric heat kits. I think the last one I worked on, this was a heat pump. What was it? Was it that heat pump package unit? Oh, no, guys! It was a Magic Pack heat pump unit. I got lucky and I replaced the relay for the electric heat kit and the relay for the blower motor. I think that one was in November or December, and there was another one. This had to have been a couple years ago. I got lucky with that. I had to replace a sequencer. But guys, the point is, you could try anything. And like I said, guys, I tell customers this all the time. I'm talking like customers with 30, 40, 50-year-old units. It's your job to, of course, diagnose the issue. And like I said, guys, based on your findings, if you feel it's worth fixing and you can guarantee what you do, it's going to work, then obviously you can go for the repair. But guys, sometimes you can't get too nearsighted, and once you get too zoned into fixing things, guys, the point of what you do is to guarantee it's going to work, and that's something you should obviously explain to customers. But the point is, guys, anytime a customer asks me with a 30, 40, 50-year-old electric heat kit, oh, hey, Drew, can you just get me by, for 3 months, or can you get me by for 4 months? I'm saving up for a new heat pump. I can totally understand where they're coming from, guys. And like I said, you try your best to make it work with what the customer had. But guys, once you start getting into fixing or replacing heating elements and replacing sequencers, there is a good chance that, like I said, guys, the age is the age. And once again, I said this before, this is that proverbial pyramid. And like I said, guys, the customers may not like this, especially if they're at that mountain. But guys, look, 0 to 10 years, I'm talking heat pumps, furnaces, boilers. In this case, guys, we're talking about electric heat kits. 0 to 10 years, I can guarantee the customer might not even know that they have a unit down there unless something's wrong. Or if a customer is proactive, if they're replacing filters, that's the limit to their interest with the equipment, guys, because they don't have a reason to check it if it's working. You understand what I'm saying? But guys, 0 to 10 years, problem free. PF, problem free. But once a heat pump gets to that double-digit age, guys, this is where you have to understand, and hopefully you guys are educating customers on maintenance. This is where maintenance is important, guys, because without maintenance, there is no way we can check amps on the electric heat kit. There is no way we can clean. Maybe there's cobwebs. Hopefully the customer replaced the filter, but maybe there's cobwebs inside the electrical component area, guys. If you don't clean this, eventually it's going to build up until something breaks down. That's just common sense. But guys, anything can happen on an air handler with double-digit age. And like, guys, what I did when I was there was I told her that, like I said, even though I put the thermostat in on that particular call, I'm talking to the customer that called me earlier today. I told her when I was there, I tested everything and it was working, but I would definitely start saving up for a new air handler. And guys, that's something I do. I mean, like I said, guys, I have no problem or no issues in telling you the tricks or my methods, what works for me. But like I said, guys, anytime I get lucky, or in this case, guys, like I said, I don't do guesswork with repairs. If I can guarantee something's going to work, I'll do it. But if it's less than a 50% chance of working, at that point, I'll bring the customer to what I'm seeing, and I'll just explain to them of why it's not recommended for me to make that repair. But in that case, guys, like I said, the customer understood while I was there with the age of that air handler, she understood that there's a chance that this thing can crap out and we won't be able to find parts for it. But guys, luckily I said that, and like I said, the customer called me back and she's like, hey, Drew, you remember you came out a few weeks ago or a month ago to replace the thermostat? And I was like, yeah, what's going on? She was like, yeah, my heat is blowing out cold air again. But she was like, I did remember you telling me that my air handler is starting to get up there in age. And she was like, tell you what, tomorrow, can you just send me a quote to replace it? And I'm like, sure, I can definitely do that. And guys, like I said, if I never would have told her that, instantly she would have just called me and I would have been a totally different scenario. She would have called me and was like, hey, Drew, you replaced the thermostat? Can you come out and take a look at it? And guys, you always want to educate customers on life expectancy with equipment. That's just part of your job. Like I said, guys, the customer is not going to know this. You're there. Like I said, this is your job to educate them, not on what you're there for, but also what to expect moving forward. Anytime you got a system, 15 plus years, unless, like I said, someone's trying to obviously lie to you guys. Like I said, it's not my job. Any AC or heat unit past a certain age, in this case, I'll give you guys real life numbers, 12 to 15 years, automatically it should already have maintenance done to the system. Once you get past that point, guys, expectations goes out the window. And guess what else goes out the window? Guarantees. Guarantees go out the window. And guys, this is not something I wanted this customer to call me to go through again. Luckily, it was just a thermostat, guys. But like I said, I carefully explained to her that there's no guarantees virtually on repairs on the heat pump past a certain age due to the fact that her system was like 30 years old, guys. And like I said, was it worth, like I said, trying to, maintenance was the only thing I recommended. But at this point, guys, she called and she said that that particular air handler was blowing out cold air. And me knowing that was just a conventional air handler, and I just put in a T6 thermostat, guys, I knew that maybe one of the elements shorted out. But guys, like I said, putting two and two together, something that old, we did give it a shot, and we replaced the thermostat. But like I said, guys, is it worth me going back there tomorrow and winding up a new element? replacing a sequencer. Like, fuck that, guys. Like I said, this is just me. I'm telling you guys what works for me. Like I said, everything that, and like I said, guys, this is the beauty of perspectives. I'm giving you my perspective, guys. Like I said, I got very, very lucky with the electric heat kits that I fixed because it was very, very small and isolated issues. Now, am I telling you to start winding up new elements? Probably not, guys. Like I said, if you want to do that, then I mean, hats off to you. But like I said, guys, I like going with guaranteed repairs. You know, I've seen this before. I've seen this a while ago of people winding up elements. If you wind up elements, you could technically, I guess, replace the element. But like I said, guys, you got to be real careful with rewinding elements because if you make this too big or too small, now you change the output of what you're doing. And therefore, you're going to have a recall. And that's not something I want you guys to go through. So recalls is a bad thing, guys. Whatever you do, make sure you can stand behind your work and make sure you can have some type of warranty and guarantees with your work. You know, any repairs you make, you know, that's how you guys build up clientele. That's how you build up customers. Make sure what you do, you can guarantee it. You know, I'm not telling you guys to try something just for the heck of it. And now the customer's calling you 5 minutes after you leave. And like I said, guys, that's not how you do good business, you know. But anyway, guys, back to the topic. With these electric heat kits, there's not really much to it in regards to troubleshooting. I can tell you right now, and I'm going to go through this real quick. And let me clear some space up here. I'm going to draw like a little air handler on the board so you guys can see this here. Because me trying to explain this without you guys seeing it, or without me being near the equipment, it's not going to work. Hold on. All right, so here's what we got. Let me wipe off the board a little bit. So we got our air handler. We got our coil. And I'm going to draw this exactly like the one that this customer has that called me. Let me write this up here. So you have the element. 10 kW. Electric heat. And I'm using different colors just to highlight certain aspects of what I'm saying. So it'll be easier for you guys to follow along here. And here, RW2, you got your O, got your G, so on and so forth. Got your thermostat connections. This one had a little, it's like a terminal strip here. And here was where we had our sequencers and our relays. And I gotta get a different color here. Hold on. And guys, I'm gonna explain what I'm drawing in a second. Hold on. Let me switch. And I'm gonna put R for relay. And I need another color for my breaker here. Hold on. L1, L2. All right, guys, hold on. I might explain this here. Good point, yada, yada, yada. All right, so guys, check this out. Let's get to this here. So guys, here's the air handler of what I just explained with that customer. This is the EVAT, this is the blower motor, and this is my incoming power. All right, this is my L1, L2. All right, and this is my electric heat kit. This and this is the same thing. This is just the electric heat kit disconnected with the Molex plug, but this is how everything looks hooked up. You got your electric heat kit. You got your heating elements here. Here you have your sequencers and your relay. And then here is your low voltage. Here's your thermostats. Now, guys, I don't have to draw the transformer because at that point, her transformer, everything was working fine. When I was there, guys, with this particular system, when I got here, she had a regular, I don't even know, this is one of those older Honeywell thermostats. But guys, when I got here, this is a no heat call. Everything was working fine. Well, no, sorry, nothing was working at all. She said that when she turned the thermostat to heat and she cranked it up, I think she said that nothing was blowing at all. And guys, when I got there, I think the unit turned on. I'm talking the heat turned on, but it took like almost 3 minutes. I think the unit turned on after I took the door off. And I think I got this on video, guys. I forgot the name of the call or the job title, but pretty much, guys, I thought that the thermostat was on a time delay, but it wasn't. And ultimately, what I had to do was I had to basically make sure I had incoming power to the unit, and I made sure that none of my safeties were off, or none of my safeties were active inside. I think the AC drains, they had a condensate pump, but it wasn't any low voltage safeties or anything like that tripping the low voltage circuit. But everything checked out. I had incoming power, and of course I had 24 volts from R to C. And guys, pretty much eliminating all my safeties, I went back to the thermostat, and then I found the thermostat not making good contact, I believe between R and W2 on the call for emergency heat. So guys, putting two and two together, I just popped in a new thermostat. I tested heat and AC a bunch of times, and everything rocked out fine. So, but guys, here's the point, right? Now I'm going to give you a different scenario here. Let's say if I had to go back to that particular call. At this point, guys, I can tell you now, here's exactly how I would diagnose the problem, right? And let's say my two fingers here are my meter leads. First thing I'm doing is I'm going to check for 240 to that air handler. Now, mind you guys, the only thing that got done here was we replaced the thermostat and we popped in a new filter. That's it. Nothing else is done. No maintenance or nothing. So what I'll do is I'll check for 240. Now, if I have 240, guys, instantly the next thing I'll do is check for 24. Now, I don't have to write this, guys. Like I mentioned this like a bunch of times, but you have a transformer that steps your incoming power down to control voltage. Control voltage is your 24 volts. But guys, the biggest thing you want to do after you check primary power, because if you don't have primary power, nothing else matters to what I'm getting ready to say. But find out where your incoming power is to your air handler and be careful. Like I said, don't touch any bare wires. Make sure, like I said, you locate your incoming, which is L1 and L2. Check for 240. If that checks out, next you go to your 24. In this case, guys, locate your low voltage wires, whether you have a board like newer air handlers or if you have just wires like this older air handler. Locate your R and C, which is tapped off your secondary side of your transformer, and make sure you have 24 volts. If you don't have 24 volts here and you have incoming power here, then chances are you have an issue with your transformer. But guys, that wasn't the issue when I was out there. So move it along, right? If I did that, and I do have 240 and I got 24, the next thing I'm gonna do is make sure my T-stat is calling. All right. Now, if my T-stat is not calling, I will still have incoming power and I'll still have 24 ready to roll. But if I don't know if my thermostat is calling, meaning if I don't know if the thermostat is set to heat, and if I don't know if the set point is set high, or if the set point is set high enough, then I have to stop what I'm doing and I have to go to the thermostat and make sure that it's set to heat and it's cranked up high enough. Otherwise, nothing's going to turn on. And guys, I eliminated this over the phone when I spoke with the customer earlier. I asked her what temperature she had the set point at and what was the room temperature. And guys, and just to remind you, we just put it in this thermostat. And she said that the big number, which is the room temperature, was 68. And she had it set to 73. So guys, hopefully you guys understand how thermostats operate, but whatever you set it to, the room temperature, obviously, if the system is working, if you have the set point set at a certain number, the room temperature should match the set point, and then the unit turns off. In this case, guys, the set point was staying at 68, she said. and she had it set to 73 for a couple hours, and the big number, which is the set point, which is the room temp, didn't go up. So obviously there was a gap in the set point in the room temperature, guys. So the point is, if I was there right now, this is exactly what I'll do. I'll just go to the thermostat and I'll make sure that my set point is set up high enough. If I know that this is happening, assuming you guys know low voltage wiring and low voltage control, like I already made a bunch of videos about low voltage controls and wiring, but assuming you guys know how to check this, the biggest thing I want to do, if I know if my thermostat is calling for heat, you got to understand heat pumps. It's no R and W, guys, because this isn't gas heat. This is electric heat. The first thing I'm going to do is go to R to O and make sure that my thermostat is calling for my, and keep in mind, guys, this customer doesn't have a heat pump. And that's one thing I mentioned earlier. This customer has a straight AC condenser. So the only source of heat this customer has is electric heat. And once again, guys, she's cool with the high energy bills, which is, like I said, crazy. But if this customer goes through us to replace this unit, of course she'll still get an electric heat kit, an air handler inside, but we're going to update that straight AC unit to a heat pump, which should allow this customer to have, like I said, a backup heat. Technically, your indoor system is the backup heat, but like I said, guys, I think 30 years ago, I don't know. She said it. She had this set up now since she's been there, but I looked at her next door neighbor's system, guys. Everybody else outside got heat pumps. Hers is the only one that only has one source of heat, which is the electric heat. So, but guys, anyway, real quick, getting back to this, and Jay reacts, what's the set point? The set point here was, I'm just hypothetically writing this up here. The set point she said she had it to was 73, and the room temp was only 68. She said she had it like this for a couple of hours. So, like I said, and right now, guys, in PA, it's not that, I mean, it's not hot and it's not cold. It's like, 55? It was maybe in the low 50s right now. So it's not really that chilly. But like I said, being at the house is at 68 and not going up, I know that something's definitely going on with the heat, with the system itself. And we already replaced the thermostat there a few months ago when I went there. But guys, real quick, with her particular system, the O is not hooked up because there is no heat pump. So how we did with that thermostat, we just put in a regular T1. It wasn't a T6. It was a regular one heat only, one AC only thermostat. It's weird, like I said, but that's just how the system is. And when you guys program these thermostats, you have to know what type of setup it is. If you have one heat, two heat, you have to make sure you know that. So when you program these T1s and T6s, the appropriate system turns on. You don't want to have, like I said, a one heat thermostat on a heat pump and air handler because, guys, remember, if we had a heat pump outside, our heat pump will be our O or our first stage, and this would be our W2 or second stage. So if this customer did have a heat pump, then we'll have to upgrade to a T6, which is a 2 heat, 1 cool thermostat. But guys, I didn't have to do that because this is a straight AC condenser. So if this is a straight AC condenser, there's no heat. This is just straight AC. And there's no W2. It's just a W. So that technically, guys, this is an R and W type of setup, similar to what you guys will see with gas furnaces and boilers. And this isn't a conventional setup. Once again, guys, I'm putting in a brand new thermostat on an air handler that's like 20 plus years old. So it was a little confusing too. But like I said, guys, I had to double check and triple check to make sure I didn't see a reversing valve outside, and I didn't. The only thing I've seen was just a compressor and an outdoor fan motor. So, but yeah, guys, like I said, what the next thing I'll do, and guys, what I'm doing right now for you guys is just checking this out. I'm just hypothetically, I don't have to go back here to diagnose this because I already knew this the first time I was there. But if I had to go back there to diagnose this system, this customer called real quick and said that we came out there to replace a thermostat a month ago. She had a 30-year-old air handler with electric heat inside and straight AC unit outside. She said that right now she got the thermostat set up to 73, and she said that she got cold air blowing out the vents. And she said nothing was done or no breakers were tripping after I left. And I knew that the heat and AC worked. When I left, I turned each one on multiple times just to make sure the thermostat was clicking everything off and on, and it was. But real quick, if I had to go back there, I'll make sure my incoming power is good. I'll make sure that I had 24 volts from R to C, which indicates my transformer is okay. And third, I'll make sure that my thermostat is calling. Okay. And like I said, guys, the only thing I did was I asked the customer over the phone what temperature she had the set point at and what was the room temperature. And she said that the room temperature didn't go above 68. So obviously, I know she had the thermostat set high enough, which is exactly the number we had it set to when I left a month ago. And if the power is on, she said all the breakers are on and the set point is up high enough, we should have some heat coming out our electric heat kits here, guys, but we don't. Putting two and two together, guys. I mean, to each his own, guys. Like I said, I don't need all the information to make, like I said, an accurate judgment, especially since I know we've been here. I'm not diagnosing this over the phone on a brand new customer, guys. I already seen exactly what I'm showing you guys this year. I seen this the first time I was there. I know she doesn't have a heat pump, and I know everything was working, like I said, when I left, and there was no safeties, nothing else that could cause intermittent issues. If you guys don't know what intermittent issues are, intermittent issues means if something doesn't work when you're away, but as soon as you get there, it turns right on, and as soon as you leave, it breaks down again. So guys, intermittent issues are inconsistent breakdowns. It does something randomly throughout the day, but then it goes away. So that's not what the customer had the first time. The first time, nothing. It took like almost 3 minutes for the unit to turn on, and as soon as I eliminated all the safeties, that led me to replace the thermostat the first time I was there. So, guys, I never had to go back there. Like I said, she just called back, and once I knew that the set point was set high enough, if I had to put money on it, guys, I know either her element burnt. Well, how can I put this? I mean, I've seen electric heat kits trip breakers, but I mean, if you had an open element, chances are, and I'm gonna write this out here because like I feel like this could happen. So let's say if one of her elements were open, I can guarantee one of the either side of this element is probably gonna touch another piece of metal, and this will trip the breaker. So I mean, like I said, guys, and that's another thing. I'm playing the devil's advocate because once again, I told you guys, if I know I'm getting power and I know my thermostat is calling, this is all I need to confirm. And like I said, guys, this is assuming that everything is hooked up right. I don't want to confuse you guys. This is just on a regular no heat call. I already been here, so like I'm privy to more information here, with what I'm drawing. But guys, with any type of system, I'm talking like any no heat call on the air handler. Once again, on the air handler, we're not talking about a furnace or a boiler. If I'm troubleshooting an electric heat kit and I know I have incoming power and I know I have 24 volts, like I know my transformer is okay, I know I got a good thermostat and the thermostat is calling, if my circuit between R and W2, if this was a two-stage heat, if my low voltage circuit is closed and I'm not getting amps on my electric heat kit, then I will recommend stepping back. At a bare minimum, I'll say the customer needs a new electric heat kit. Now, the reason why I said step back is because if the whole air handler is 30 years old, guys, is it worth trying to hunt down a new electric heat kit? That's a decision the customer has to make. Now, if you can get parts for a certain brand, guys, sometimes you can get lucky and get a new electric heat kit. But like I said, like I was telling you guys, I explained all this to the customer when I was there the first time. I said, you know what? Just to show you, today was just a bad thermostat. We popped a new filter in for you. And also, what we'll do, and I said this in the winter, I said what we'll do is we'll come back out in the spring. And like I said, we'll come out and check the AC. But I told her that if something happens to this air handler in the future, whether it be the electric heat kit, it's going to be very hard for us to find parts for this unit. And she might have to look into replacing the unit. And she was like, yeah, I understand. But if there's a way we can just try to keep this going, I'm like, yeah, we can try with maintenance, but in the meantime, I will definitely put this on your list to do as far as to, your next appliance to replace in this house will probably have to be just replacing this air handler. Because I told her at best, keyword, at best, we can try to keep this unit clean with maintenance. But guys, age is age, And like I said, guys, I used to be that guy. And like I said, guys, I'm very honest and transparent with you guys. We used to replace a lot, I'm talking from 2016 to 2018. We repaired a lot of things. And guys, there's goods and bads. There's pros and cons to almost every decision you're going to make. on service calls. The pros of repairing things is like, maybe the customer doesn't have it in their budget to replace a whole system. I get it. But guys, and I mentioned this in previous videos, guys, there's a downside to over fixing something past a certain age, because now once guarantees and like I said, guys, once certainty and guarantees go out the window, I don't want to be I don't want to be that company that customer calls. Hey, Drew, you guys are just out here last week. I know you spent like 2 weeks finding parts for this air handler, but hey, it's doing the same thing and it's 20 degrees outside. I mean, I know we've been going back and forth now, but it's been almost 2 weeks. Like, what can we do here? I already spent $2,000 on this. Yeah, guys, like, that's not going to be a play. Like I said, guys, that's just business. We do everything in good faith, but like I said, guys, sometimes over fixing things past a certain age, it doesn't work out. Like I said, you're not being a smart ass telling that to a customer. But like I said, guys, I fought plenty battles, and like I said, I can tell you from experience, always try your best to give them repair versus replace. If you can guarantee your repairs as a company, if you guys are running your own shops, if you can guarantee it, then do it. But if you can't guarantee fixing something, then don't feel bad or don't think you're not doing your job by telling the customer, hey, Miss Smith, or whoever the case is, if I try doing this, we can try it. But if it's not guaranteed to work, then now I'm wasting your time and I'm wasting your money. Because guys, look at this. The customer probably took off work for you to come out today to diagnose that system. And now, even if she's paying you to fix that air handler or to fix that electric heat kit, guys, if it breaks down again, like I'm telling you guys, the shit can turn into a disaster. So guys, I fought plenty of battles. And like I said, my personal, my professional opinion, my personal opinion on this will be just to replace the electric heat kit at the minimum. And if you can't find the electric heat kit, just tell the customer to replace the whole air handler, because it's just, I've seen this before. I've seen guys, I guess, buy the electric heating element and you wind them up. Guys, like I said, I'll probably do that shit just kind of like for fun, but I wouldn't I wouldn't put that in someone's house, because guys, I'm telling you, man, like I said, doing that, if you mess up the resistance and now you're putting something in smaller or bigger than what you're taking out, now basically you altered the whole unit. And do I want to stand behind doing that? Probably not. We're not talking about a garage play unit. We're talking about an actual system that someone depends on, for heat and AC or whatever the case is. So guys, just be very careful, like I said, with what you guys do with these electric heat kits. If you got a good model and serial, call your local supply house and they can try to find a new heat kit. But we're talking residential. Very rarely, from my circumstance, have I seen it has it been beneficial for us to just fix an electric heat kit. I really never seen, I got lucky 3 times, like I said, but that was just kind of like on the whim of the moment, And like I said, I can tell you like this. We're going to use the same format here. I'm going to show you something here. With that, I think the relay that I replaced, that was a heat pump. What the hell is that? I think that was a Magic Pack heat pump unit. And guys, those Magic Pack units are very they're a little bit more complex than like a conventional air handler, because what you got to realize is it's a whole lot bigger. And like I said, your electric heat kit could take up almost half the space. But guys, in regards to that heat pump Magic Pack unit, instead of having all the sequencers and relays in one spot, it was a lot more space to deal with. So it's easier for me to diagnose technically, having everything blown out there on the heat pump Magic Pack unit than it would have been on the conventional, like residential, 10 kW electric heat kit. So guys, like I said, that's something that, that you gotta ultimately use your own discretion. Like I said, I don't know. Sometimes, like I said, guys, this is the interesting part about perspective. Sometimes you can get lucky with fixing these electric heat kits, but like I said, guys, once you get kicked in the nutsack fixing these things a handful of times, you'll know what will be the better judgment moving forward, what you have to do. And like I say, even though you can identify all the parts on this electric heat kit, mind you, if this thing is new enough, you can probably get a whole new electric heat kit the same day. Like if this is like a Goodman 10 kW electric heat kit, under 10 years old, that's a slam dunk. You're good. You can get a whole new heat kit. But like I said, guys, once you start getting into these 30, 40-year-old electric heat kits, where like I said, everything's the same color, you don't have a model serial number. And like I said, guys, this, man, and like I said, guys, the best thing you can do is just be honest and transparent. Like I said, you know, you don't have to take it personal. If you got to tell a customer that, hey, look, ma'am or sir, we can try to fix this, but it's going to be a good chance that this might not work. And if we do get lucky, I can't guarantee how long it's going to stay on for, because this isn't, like I said, a conventional type of diagnosis. We have no modern serial. We don't, you know, even the supplier told us we got to find an aftermarket sequencer. And guys, doing all that, you know, it's best to just do your job and let the customer know what to expect past a certain age, 12 to 15 years. Ultimately, if they have someone coming out to do maintenance, that maintenance technician should educate them on what to expect moving forward. And what to expect moving forward, in her case, I told her to just start saving up for a new air handler and a new heat pump. And that's what she did. But she did call me back, like I said, today, and said that the electric heat kit crapped out. So, guys, like I said, I covered my tail, and I definitely want you guys to do the same. But like I said, first things first, I'm not recommending you guys just, you know, going out to a customer's house and tell them they got to replace a unit just because. No, you do your due diligence, and you make sure, like I said, you know, you cross off your T's, dot your I's, and you can definitely zoom in and make sure that you know what the issue is. I'm not telling the customer, hey, ma'am or sir, you got to replace the air handler just because it's not working. If I hear that, I'm going to say, okay, well, how come it's not working? That's why I called you out here to begin with. What's the actual issue? And if I look at if a customer tells me that, and I can't explain to them what I found, then like I said, guys, that's going to look bad on you as a technician. So make sure, first things first, you got a core understanding of how this stuff works and how to diagnose it. But like I said, guys, once you know how to diagnose it, once you start getting into trying to find these 20 plus year old electric heat kits, is it worth it? Probably not. So there you have it, guys. I gotta rock out. I gotta gas up one of the trucks, and I gotta hit the road. But yeah, guys, I mean, to each his own with these electric heat kits. Like I said, guys, if you feel comfortable and confident with fixing them, I mean, be my guest, go at it. But you know, we got very lucky on that heat pump magic pack unit where everything was blown out and we had space to actually replace those relays. But guys, I even told that customer, like, we got very lucky with him having the external relay. It wasn't like everything wasn't compact, but I even told that customer with the magic pack heat pump unit that eventually it's going to be hard for us to find parts for this brand. And I told him to just start saving up to get another magic pack heat pump unit. He understood me. So like I said, guys, it's definitely just, like I said, it's your job not only to fix the immediate issue, but it's your job to educate customers on what to expect. You got to manage expectations. You know, if you don't manage expectations, now that customer is going to think what you did right now is going to satisfy them for 20 years. It doesn't work like that, guys. You know, HVAC in a nutshell, we're cleaning and we're fixing machines. You know, anything with electricity going through it, you never know, you know, what can happen down the line. That's why customers pay you for maintenance, so you can keep everything clean and you can stay on top of things before they break. But once you get to that proverbial mountain and things start to break, now the customer has to make a decision. Is it worth fixing, or they have to look into replacing the unit? So, but yeah, guys, that's all there is to it. I'm going to rock out. I appreciate y'all for checking in, and I'll see y'all in the next one. Peace.